Ladies and gentlemen, hello, and I really appreciate the invitation to myself as representative of the old economy to the very new and dynamic economy that you are representing. I'm very happy to get in contact with the data scientists community, which is much talked about in our community in the context of Industry 4.0, but unfortunately which is in our environment not really much visible. So my first question to you would be, is there anybody of you representing a manufacturing company? Oh, great. So I can see that there are some manufacturing companies who already have plants already digging into this topic. I congratulate to that. What I would like to talk about today is to first briefly introduce SwissMem and our initiative 2025 very briefly, and then I would like to use some more space to introduce this concept or this topic of Industry 4.0, as there is, in my eyes, many misconceptions about this term, and I frequently see that there is a need to clarify or to build up a common understanding about what Industry 4.0 is. And then I have a number of examples of use cases which should demonstrate what the solutions or what the implementations could be from our point of view. And to conclude, I have some remarks or some thoughts about the link between data science and the manufacturing industry. So SwissMem, I don't know if everybody is from Switzerland and is aware about what SwissMem is. SwissMem is an industry association. We are representing the manufacturing industry, the engineering manufacturing industry. We have 1,050 members and fully financed by membership fees. It is always very unclear how we are financed, but it's really independent or industry representative organization. And the industry that we are representing is manufacturing these kind of products, so from very heavy machinery, multi-ton machinery, to very small medical instruments, for instance, very precise, but also all types of electronics, electronical equipment, all the way still to vehicles and trains that are manufactured in Switzerland. SwissMem has roughly 85 employees. We are also active in education, so we are the responsible body, for instance, for the VET, the vocational education of the mechanical design, the electronics, mechatronics, and so on. The initiative that was mentioned, Industry 2025, was founded a little bit more than 1 year ago, in June last year, as a platform to pool the activities and the information regarding Industry 4.0 in Switzerland. I mean, the topic itself, as I will demonstrate afterwards, is not new, but the Swiss companies, we made the experience, if you talk about Industry 4.0 or digitalizing industry, they're always thinking, yeah, that's something that comes from the north. This is a German initiative that doesn't really matter to us, and it will be a hype, it will go over, and yeah, I mean, it's not really something for us. And there have been many questions if that is really a hype only, or if it will really affect the Swiss industry as well. So there were many companies still hesitating in taking up the lead and in getting engaged in the topic. So we thought that we need kind of a Swiss umbrella to raise the awareness in Switzerland with the companies, to inform firsthand with a Swiss label the companies about what is going on and what the future will be. So we decided together with 3 other associations. Swiss TNet is an industry association in the robotics automation field, so a technology provider association. Also may be known the telecommunication association in Switzerland, and ElectroSwiss, there is the mechatronics department of the power suppliers here in Switzerland. So we founded that with the clear goals to inform, raise awareness, to network the different players in the field, and to promote the topic amongst the Swiss industry, but also in politics at the schools, for instance. We have 4 fields of activities, primary activities. First is the networking and knowledge transfer, where we have a range of events that we are organizing ourselves, but also as today we are contributing to many events in the whole industry. So we are 3 people speaking on the topic always weekly. We have podium discussions, presentations. Then it's the field of support. We noticed that many companies are unsure or need some support in getting into the field, so we are organizing workshops together with partners to open an entry point into the topic. Then we have the technical topics. I'm not just talking about it, but really getting some meat, also flesh on the bone, where we are collaborating with our partners in working groups. We have white paper studies on our website, which get in deeper into specific topics. And then the 4th field is innovation support, where we are organizing R&D conferences to exchange know-how between the scientific community and the industry. I mentioned partners. The industry associations themselves, we can also only provide the framework, but the content really has to be provided by other bodies. That's not a field that we can do. So we have the concept of partnerships with network partners, companies or organizations which help disseminate the topic, but also thematical partners, where we currently have 27 partners. That's business consulting companies, that's standards organizations, that's GS1, that's engineering companies, that is Swisscom and Cisco, who are partners, so IBM in the cognitive computing field. So we have a range of partners which help us getting more flesh on the bone. To build up the understanding of Industry 4.0, I think there are many myths around this topic, nurtured from different views and different companies or different organizations, but there's really clear route to where this term Industry 4.0 and the concept of Industry 4.0 comes from. So really the beginning was in 2011, when the ACADEC, the German Academies of the Technologies and Sciences, they decided to start a working committee on advanced manufacturing, and during the work of this working committee, the term Industry 4.0 actually was born. And at the Hannover Fair 2012, there were first presentations held on this topic and on this concept. They continued their work and presented the final report of this working group or the working committee to Chancellor Merkel at Hannover Messe 2013. And at the same time, this federal Zukunftsprojekt Industry 4.0 was launched, alimented with 200 million euros to start projects in academy, in applied research and at the company. So this is really the root of Industry 4.0, and from then on, 2013, these different activities started out. Also in the same year, to offer a platform to the activities, there was the German platform Industry 4.0 founded by the German Industry Association, VDMA, our partner Machinery, Bitkom, ICT and Zweig Electronics and Electrical Industries. They were the supporting body of this platform. And then of course this is when, in particular in Germany, this, you can call it hype to some extent, the Industry 4.0 started, when it also got the main topics at CeBIT. And a strange turn took place in 2015 when this platform Industry 4.0 was taken away from the industry representatives and the federal ministries of economy and education and research took over the responsibility. This is quite a strange move from the Swiss point of view, because it should be the industry who is driving it. Nevertheless, they're working still on it, and the German association VDMA, our partner, they started a new platform really to support the companies, because that actually turned out more into a political platform rather than in a platform supporting the industry. So this is really the term Industry 4.0 and the whole concept there are these reports, they're downloadable from this platform, Industry 4.0 website. This is really describing what Industry 4.0 is. In the meantime, there were several international activities started. I won't read through it. You can see it mostly in Europe, also in the United States. It's the Industrial Internet Consortia. And what is different between these and this one, these are all started from the manufacturing point of view. So it's really the applicants who are in the driver's seat if defining their needs and the roadmap where they want to go to. However, this Industrial Internet Consortium in the US is mostly driven by the ICT companies and providing infrastructure. That was the main goal. So it's not really following the same goal as these European activities here. Excuse me. This Industry 4.0 is used as a short term for the fourth industrial revolution. You can have lots of discussions with the evolution. I won't go into that. I've seen presentations where they discussed 15 minutes about the topic. Doesn't matter. I think from the industry point of view, the critical issue is that there was a lot of digitalization already in the third revolution, in the 70s, when the chips got available and affordable. There have been a number of developments, mostly in the ICT field, which have advanced the use of these technologies in the industry. Of course, everything got cheaper, but it's you can read it there and think it's for this community it's not really new. But there are a summary or a pool of developments which led to these visions that we read today in the newspaper about what is possible. And as a side mark, I think what you read in the newspapers and these reports, also from some business consultants, that's really a vision. That are visions which are based on what is technologically available or possible or thinkable, but it's never. It has almost never done a reality check. Is it really affordable? Is it really, can you make a business case out of it? Will customers accept it? So this link with reality is usually not made. So it's visions which is not really so relevant to the work that happens at our companies. And there is, in fact, even though people frequently say there is no definition, no clear definition of the Industry 4.0. There certainly is not a clear definition, but there is a definition, a broad one, with a lot of grey zone in this report from the working committee, and it's a lot of text, but I show you this picture to make it probably a little bit easier to understand. Basically, there are two fields of action as a company, as a manufacturing company, where you can work on. The one is the value-added chains, value chains, not only within the walls of your factory. It's really the whole value chain that the companies or enterprises are looking at, and it's the question of optimization. The production equipment at your factory, it's the question of optimizing processes, optimizing the value chains across the companies, and the term whose has been introduced here is also value-added networks, not only chains. And with digital tools and the digital technologies, you can of course have good tools to optimize and make it more efficient, make more efficiency in these value chains. And the second field of activities is on the market value, so to say. The products, services, the life cycles that you can control or manage as a company, so really much more on the customer side. Of course, the customer also has value from here because the products get cheaper, but it's really it's more the value chain view, and it's the market view that you can have as a company, and that leads on. That leads on one hand side to the increase of productivity and agility, and that is really what the Swiss companies are needing right now with the strong Swiss franc, and I think you're familiar with the topics, with the increasing costs due to regulations. So we are in a difficult situation here in Switzerland, mostly in terms of productivity, not really in terms of market services. So efficiency, productivity is certainly one goal, The second goal, of course, is providing new innovations for the market. For me personally, that's probably the more important topic than the top and the bottom one is new business models, because of course both fields of action here provide opportunity also to introduce new business models, and companies tend to say, yeah, we want to improve and we want to get more attractive on the market, more competitive, but ignoring new possibilities for business model, modified, extended business models. I think that's, in my personal view, that's not the right approach, because in this field, if it's about business models, as we know from the web, from the internet, from the ICT community, that has usually quite a low entry point. And if there are some companies or organizations entering into such new business models that are offered also in the old economy, if they are lost to these new companies, the traditional companies will never get it back. So the companies, in my opinion, really have to be aware what are usually rather low barrier opportunities for them, and they have to tackle these fields and not focus only too much on these fields, because in particular here, I think you have probably a little bit more time to improve yourself rather than in this new business model field. And what is important, which is seldomly discussed, by focusing on these fields, you can look at the Industry 4.0 concepts either as a user, as a company who applies these concepts on technologies, or you can look at the topic as a supplier to this field. I think it's important to discriminate these two views. So what are the opportunities for the companies? And I have introduced this slide here, which I found, being a picture, shows a little bit more, shows better what the opportunities are. And this is a concept of 4 different approaches. One is the horizontal integration along the value-added chain. So there are a lot of opportunities where you can have projects along this value-added chain. Then there is the vertical integration in your company, and that's not a new topic. I think there's a clear understanding on that there's always a huge potential for vertical integration, but these Industry 4.0 concepts can support you there. And then as a third approach, there's the integration of engineering. Digital engineering is a term that is usually used here. It's mostly looking at the life cycle, and these are both horizontal axes here, and in my opinion, there are huge opportunities here to combine these two today mostly separated systems. So we're talking about the value chain here, about ERP systems, production planning system, manufacturing execution system, and so on. And you get a lot of know-how and data along this value chain, which you can also use in the life cycle, in the PLM here for product life cycle management, product data management, along the life cycle, also after sales and all the way to recycling. And by getting these systems together, I think there are huge opportunities for the company. And the fourth one is, of course, the technological view from, you mentioned the sensor, from the very bottom end all the way to cloud technology, to the technological hierarchy. So you have 4 approaches, and these the dimensions here offer kind of a playing field where you can implement what we call use cases anywhere on this field, and it's not mainly a question for the companies to think about what could we possibly do, what could be interesting. It's the companies usually should ask themselves, where do we have shortcomings in our processes or in our value chain that we can work on. Really, usually have the first implementations on a smart scale to gain experiences, and so they're looking for use cases anywhere in these large fields. And such use cases have different dimensions, from technologies, question of data, semantics, processes, method models, and so on, all the way to the questions of standards and safety security. So this is usually the approach that we recommend to companies in starting into this Industry 4.0 journey. I haven't talked much about technologies, but I realize that in media and in reports and studies, usually technologies always come up first, from additive manufacturing. Blockchain is not here, but there's a whole range of augmented reality, virtual reality, artificial intelligence. These are usually technologies which are associated with Industry 4.0. In our view and our understanding, these are technology which are part of the solution to implement a use case. It's not one of these technologies themselves is Industry 4.0 directly. And if you look at these use cases, you might use some of them, you might use none of them. And this is the question, this is the big challenge for the companies really to find out which way to go through these various technologies. And also what we usually tell people from these technologies, and there's no complete this list here of course, to implement use cases at the companies, at least 90% of the technologies are available and are ready for implementation. There are some fields here, of course, where research is required and reasonable, but from the company perspective, point of view, it's really about 90% of technologies are ready to be implemented. So it's a question of going ahead rather than waiting for some research or doing some own research. So far on the understanding of Industry 4.0. I have now some use cases which could demonstrate how such implementations could be, and also some examples, real-world examples. One of the classic examples is an assembly line, interconnected and digitalized assembly line, with the main goal to have unplanned situations detected early, and the system to suggest how to work around them and how to handle the situation and how to optimize the rest of the assembly. The question of product guiding through the assembly, something which is in particular in Switzerland is very well implemented already in the manufacturing. Mostly it's by barcode or even by manual documentation, but this flow through assembly is working quite well today, but of course there's always room for improvement or for additional optimization. And as in Switzerland, especially in the larger machinery, we don't have usually series production, so much of it is customized manufacturing and assembly. You can have interesting models of automated smart automation, which are interestingly collaborating with the workers, using their skills and cognitive skills here. A second one is, and this is particularly in the machine tools industry of high interest, is if you're manufacturing mechanical manufacturing, it's drilling, it's turning, or whatever it is, you get a lot of application data. It's the speed, how fast the tool is going, how fast it is turning, how fast it is moving, and what tools are using for which metals. So there's a lot of secrets, hidden secrets in machining, and that is today is mostly with the mechanics operating these machines. They have the know-how, and by collecting the data from the machines, from the production process, and aggregating them from different machines, you can gain a lot of know-how, application know-how, which is particularly, if you don't have series production, which is very valuable to the manufacturers, because they don't have to go through these iteration loops to gain experience, and that helps them to get more efficient in their production processes. So a good use case here is that either the machine tool manufacturers or an independent third company collects this data, evaluates it, analyzes it, and kind of generates a good practice for machining, which can be sold to the manufacturers. Also, for instance, on public marketplaces. So this is a field where some companies are actually working on today. Condition monitoring, I think that's one case which is mentioned quite often. This is actually a case which is implemented with Trumpf. This is a laser head where you have this lens here, which wears during operation, but the wear of this lens is depending on the power of the laser and of course on the time that the laser is used, and they have a diagnosis system which monitors this lens but also calculates based on models the current state of the wear, and by knowing the production plan they can tell the operator when would be the best time to exchange the lens. So not really that you have to exchange the lens at the same time when you have a big job working on it, so that you exchange the lens before this big job, which takes 3 shifts, for instance, starts. So this helps automate getting the operator of this machine to be more effective. A very interesting and actually implemented pilot line is with Bosch. This is operating in Germany at the manufacturing or the production line, where they provide disc valves as for hydraulic systems, where they have 6 basic types of these valves, which are manufactured in 200 different variants. So a very high individualization of these disc valves. And the effort to automate that manufacturing will be enormous compared to the quantities being manufactured. So it is mainly a job which is done by humans here, by workers, but they implemented a whole range of automatization and assistance systems to these workers. So starting with the workers, they are identified by the manufacturing execution system. They know where they work, so from the start here, all the workplace here is adjusted to their sizes. If they're left-handed, if they're right-handed, they have panels here where they get instructions. The instruction is in their language, which they prefer. The system knows which products of these valves they manufacture the best, so the best quality in the shortest time. So they get these jobs which they do best. And then of course there is a production planning system observing everything, and there's the classical manufacturing management systems, so production management systems, which is directly integrated with these systems here. So this is it's a pilot, that's clear, and but it's really interesting pilot here which demonstrates what is possible in terms of assistance systems here. Another example which is implemented, which goes in the field of digital engineering. These are the faucets from the company KWC, today part of Ranke, one of the big bathroom and kitchen installation manufacturers. You can see it here. And such a faucet is first it's cast, then it's being milled, then it's grinded, and in the end it's coated, as it's the classical manufacturing process for them. And what they have done, they have not only automated the grinding, which is not so easy looking at these different free surfaces that you have here. That is what the first step, but they also collect data along the whole process. And that helps them to improve the design of future faucets. So if they know exactly which of these steps takes what, how much time, how much wear on the tools, for instance, so that helps them to get the experiences and to feed it back into CAD programs to optimize the design of future faucets. I think that's a very nice example of how you can use digital engineering. Okay, so I hope with that I could give you an overview of what our understanding of Industry 4.0 is, how different facets of implementations could look like. Now the question, is what is the status in the Swiss industry? There are many reports from the business consulting companies saying it's on the very bottom. They also say it's a forerunner, Switzerland, together with Germany. So we really wanted to know from our members, and this is a big difference to most studies. Most studies, they talk about digitalization in general and give you a view of the industry, manufacturing industry, vis-a-vis financial services, vis-a-vis healthcare. So we're really looking only on our companies, because I'm convinced digitalization in the healthcare sector is something completely different than in manufacturing industry. That's a peers comparison. We made a survey in the summer of this year. There were almost 400 companies who responded. Most of them, 85%, are actually manufacturers. The rest is service providers and distributors. And we asked them first where, if and what benefits they see in this 4.0 concepts. And yes, it's hard to read now. This is the increase of productivity, so that's clear. It's Swiss companies. A Czech company probably would answer differently. The second one is here process, and the third one, process and resource efficiency, and the second one here, if I remember correctly, is a customer, improving customer service or customer experience. And then in the area of 40% here, it's the customer relationship here, and improving product and service quality here. And to our surprise is two topics here: flexible production and individualized products, which are heralded as the main goals of Industry 4.0. They're actually trailing here behind. So from this perspective, it's mostly efficiency and quality and customer orientation. And we were very happy about this result here, that 82% of the respondents actually saw at least one benefit for the Swiss industry on this topic. And the next question was, do the companies already have projects running, already implemented or planned? And we were really surprised about this figure here, that 55% of the companies responding actually have projects already running. And we not only asked about projects in general, we asked them about in different areas along the whole value chain. It was really surprising how many projects along the whole value chain were actually going on, and already 44% of the companies had implemented projects. And also, to our delight, was that there was not much difference between SMEs and large companies. So most figures that were only in 1 or 2% variations. What happened here? Excuse me for that. We also asked, of course, what are the biggest obstacles, and it wasn't technology, it was not the skills, which were not here. One, and this is the reason why we need Industry 2025, is there's missing understanding or incomplete conception of the topic Industry 4.0. And the second one, with more than 50%, and the second one is missing personal resources. So that's the result of this highly competitive environment with currently low margins that we're in, that you're just missing the resources to do innovation in general, but also tackle these new topics. And really surprised here on the open response here that more than 30% of the companies responded that they don't have a holistic strategy roadmap on the digitalization issue yet. I think this is really, these two are the fields where we can work with Industry 4.0. So coming to my last slide, for this community here, some thoughts from me on data science, the role of data. You can only see frequently see the quote here: "Data is the new oil." I think that's probably true, but probably not in the sense that the guys from Silicon Valley think of it. So I think we really have to discriminate between the internet, data, consumer-oriented world of the Facebooks and so on, from the manufacturing world. For the manufacturing world, the big value of oil is that by actually acquiring the data and being able to analyze the data, which not only come from sensors, there's a huge range of data already available in the machines, you just have to harvest that. That you gain transparency about your manufacturing processes. And having this transparency and having the data available really puts you in the position to better control the processes and the value chain. So in the first step, the value or the oil is in getting more efficiency based on the data. And as I mentioned at the very beginning, the data certainly is the key driver to enable new digital business models. And as I mentioned, with data from the manufacturing process through the life cycle, but also I think we can need some help here from the data science community, how to use publicly available data. And I really think that we have to understand that probably these worlds of the Ubers, the Airbnbs, and the Facebook and so on, the data they're working in and the business models they have, they certainly differ from the business models that are applicable in manufacturing industries. And I think there's a big challenge here in really being able to interpret the data from the manufacturing content. I asked Mr. Ruckstuhl what the community is, and here today I think here from the manufacturing point of view we have to merge the data science, ICT world together with the production world, because it's, in my understanding, it's only production guys who can interpret the data. And so the question is, how do we merge these two worlds at this interface, and how will job profiles and work tasks look like in the future at this interface? And this is a challenge, and I think we have to be aware that this is emerging, and it only works for the manufacturing world if these worlds are merging together. Of course, there are big challenges on modeling and semantics, and as we have just discussed yesterday as well, there are a lot of open discussions, open regulatory issues maybe as well, although we don't like too much regulations, of course, in terms of data rights, who owns the data. If you buy a machine, it's probably clear, but if it's a leased machine, it's probably not so clear. And if it's data that you acquire from the products from the third party, how to handle the trade secrets, and so on. And so there are different questions that we have to tackle. Thank you very much.